Hello, and welcome to this OncLive peer exchange titled TRK, or TRK inhibitors in lung and GI cancers. I'm Dr. John Marshall from MedStar Georgetown University Hospital, and I'm joined by an amazing faculty. Normally we're all together, but this time we're all around the United States, and they're joining me today on this virtual discussion. First, Dr. Tanios Tony Saab from the Mayo Clinic. Dr. Shubham Pant from MD Anderson Cancer Center.
Thank you for having me.
Dr. Jyoti Patel from the Robert H. Lurie Comprehensive Cancer Center of Northwestern University. Welcome.
Thank you.
Dr. Luis C. Reyes from Memorial Healthcare System.
Thanks for having me.
And Dr. Mark Szynski from Advent Health Cancer Institute. Mark, welcome.
Thanks, John.
So today we're going to discuss a number of topics pertaining to the use of TRK inhibitors in lung and GI cancers. So let's get started. And Jyoti, Dr. Patel, we're going to start with you. And if you could kind of set the stage for us. What really is a TRK inhibitor, and specific for you, what is neurotropic tropomyosin receptor kinase inhibitor? What are they and what are they all about?
Certainly a mouthful, but this is a class of transmembrane proteins that have been found to be oncogenic drivers. These genes are fusion events that are quite rare, but across a wide variety of tumors that when we detect these, we find that they are sort of the sentinel event for a tumor to become cancerous and to really grow. What's exciting about this is that it's a bona fide target for cancer therapy across a multitude of tumors.
Yeah, I think it's fascinating biology too about these cell receptors and the discovery of these receptors really from another field that turn it into a cancer target. Shub, Dr. Pant, maybe talk a little bit about that whole biology and what we as oncologists were sort of forced to learn as we're discovering this new therapy. Take us through that a bit.
Sure. So TRK inhibitors. So TRKs, first, they play a really pivotal role in the physiology, development, and function of the peripheral and the central nervous system. So that's one of the main roles, physiological roles in the human body. Now we have three NTRK genes, NTRK 1, 2, and 3, and they give rise to the proteins, which is TRK A, B, and C. And essentially, most of the ones we see are fusions in NTRK 1, 2, and 3 genes, which lead to this activated protein kinase of TRK A, TRK A, B, and C. And that's how that's the oncogenic driver for the growth of the tumors. And as Dr. Patel said, there are different tumors, some rare, like infantile fibrosarcoma, secondary breast cancer, which we'll talk about later, that's common with rare tumors in which it's more common, and the common tumors where it's more rare. So yeah, that's how we're seeing it currently.
No, that's a really clever way to put it. I mean, they are sort of receptor tyrosine kinases in some way. They're transmembrane receptors, right, that are ligand dependent in the normal state. And with the fusions that occur that we're going to talk about, they become sort of independent. So it's a signaling pathway. Tony, anybody else? Mark, want to chime in on your thoughts on this, on the biology of this pathway?
Yeah, no, to me it's fascinating, and when you think about the role that these proteins play in the normal state in neurologic development, it's interesting, as we'll talk about a bit later, to look at the side effect profile of these drugs. But like we've seen, in what I think is one of the poster childs of genomic tumor, lung adenocarcinoma, a number of these fusion, not only NTRK, but things like ALK and ROS1 and RET fusions and all these sorts of things that create an oncogenic pathway. As John said, it's really a growth pathway. And these are kind of what we used to call stupid cancers. They're very simple from a mutational burden load. It typically is dominated by one pathway. And these small molecule drugs that are orally absorbed are highly effective, as we'll talk about, not only in NTRK, but in a number of different fusion situations that we have in solid tumors, with obviously lung having a number of them.
Yeah. Well, we have a merger of lung and GI, so we're going to have to fight it out for the diaphragm, above and below the diaphragm for our discussion.